In Chapter 8, the entire chapter is on what we call polynomials. Just like when you first learned about fractions in elementary school, and they start off giving you some vocabulary of numerator and denominator, and then after that you simplify them, and you add some fractions, and then multiply, divide, etc. We've got a whole another type of thing next called polynomials, and we're going to take kind of a similar progression. We're first in is a lot with the vocabulary, and the vocabulary is the least important of all the things you'll learn. When, just like, for example, if you had to add fractions, it's really not all that important that you know numerator and denominator, just that you know what to do with them, but it's good to have that vocabulary in your set of tools. So 8.1 is primarily on vocabulary, and then just like with the fractions, we'll learn how to add and multiply and divide and do all kinds of good stuff with our polynomials. So let's start off with some vocabulary. The first thing we're going to talk about is a monomial. The word mono, the base word, means one. So what a monomial is it's one term, and you won't see, and I'm not giving you formal book definitions because honestly you're not going to remember them. I'm just going to give you the easiest way to keep this vocabulary straight. So it might not be 100% mathematically kosher, but it will be the easiest way for you to remember. Just think mono means one, and so it has one term, and really what that means is you won't see any addition or subtraction. For example, a monomial could be the number 5, that's just one term, or it could be 5x, and you don't see pluses or minuses, 5x, or it could be 5xyz squared, because again that's considered one term. There's no addition or subtraction. Alright, now a polynomial is monomials linked together by addition and subtraction. I guess the only exception to that is every monomial is actually also a polynomial. Poly means many. Anywho, what you'll see is terms connected, and again, this is not what your book is going to say, but I kind of like this a little better. For our purposes, this is going to work just fine. Terms connected by plus or minus. So this is actually a classification process. You could even think of it with how I could classify you guys. I could say, oh, I'm thinking of a blonde, and then say a blonde girl. And then I could say a blonde girl wearing blue jeans, and it kind of fine-tunes things. So the general thing is everything we deal with this chapter is going to be a polynomial, and then we're going to get down to naming them and being more specific about what kind of polynomials they are. So like me saying, oh, I'm thinking of a human, that does not help you. But that's like me saying, oh, I'm thinking of a polynomial. Well, okay, narrow it down for me. So we are going to do a little classifying and naming them and giving some special names to some of our polynomials that pop up the most in mathematics. Before we do that, we're going to talk about what's the degree of a polynomial. The degree of a polynomial, like say that deals with the variable, just one variable, such as x, or is the highest power you see. Now, that's if it's only in one variable. If there's multi-variables in it, you add the exponents up, but that's really not important. Just kind of think it's the highest power. You might say, I have no clue what that means. That means this. If you were to see x plus 3x to the 4th minus 1 plus x squared, the highest power I see is a 4, so I call it a 4th degree polynomial. It's as easy as that. What I was talking about with the addition is there's also in your book, it talks about a monomial, one term, and you have 2 or 3 or 4 or 5 variables, and it looks like this, and you're like, oh, well, what's the degree of that? Do I look at the 2 or the 5? And the rule is you add them up. That is really, really minor, and you'll probably, and honestly, I don't think my calculus kids would even know that's how you do it. But when it's in one variable, you need to take the highest power that you see. And that's really all you need to take from that. When we say to write a polynomial in standard form, what that means is we start with the highest power and we list highest power all the way down in decreasing order to the lowest power. Now you got to keep in mind sometimes that lowest power and oftentimes is just a single number. and that's called a constant. We'll get that in just a second. So let's go take a look at what we've got here. We have got a 1, 2, 3, 4-termed polynomial. It is not in standard form because I have to start with the highest power I see. This is third, this is a first, this is a second. This number right here, this 5, is really 5x to the 0, if we were going to think about it like that. So when I pick my highest power first, it's the negative x to the third. So that one was fine. But then my next highest one is the 3x squared, followed by the x to the first, or just the x, and then the minus 5. We just reorder them so that it goes in decreasing order of those exponents. This right here gets a special name because no matter what x is, if I were to tell one of you to evaluate this or go to your calculator and plug a 10 in for x, you'd go negative 10 cubed plus 3 times 10 squared plus 10 minus 5. If I were to tell someone else to put in a 7, they'd do negative 7 cubed plus 3 times 7 squared plus 7 minus 5. No matter what I do with that x, everybody will be tacking on a minus 5. And it will remain constant and not change. It doesn't matter what x is. We all are going to be subtracting 5 at the end. So when we don't see that variable on there, technically I guess it's there. It's just to the 0 power. And anything to the 0 power is 1. So we call that a constant. So now we're going to talk about how you name polynomials. And basically I like to think of it as them getting a first name and a last name. I like to think about it like this. The first name, like mom, comes from its degree. That's the degree, the highest power that you see. Its second name, or its last name, comes from how many terms there are. Seems confusing, but it's actually quite easy. So let's talk about the number 6. Technically, if I wanted to see the variable, I'd say 6x to the 0. So its degree is actually 0. And its name based on that degree is actually, it's called a constant. I already told you that. It's only one term, and a one term is called a monomial. So we would call it a constant monomial. That would be its name. All right, now I'm going to name this next one by both degree. Well, what is its degree? It's to the first degree. So that's degree 1. It's the highest power I see. And we call those linear. And the reason is last year in 8th grade you studied linear algebra. And this might look kind of familiar to you as y equals mx plus b. You might remember that that's kind of slope and intercept of a line. So we call those linear because their graphs make lines. Number of terms, there are 2 of them. There's a 5x and a 9. And so we've got a word in the English language that means 2. And that's bi, like for a bicycle with 2 wheels. So we call it a binomial. And again, this vocabulary isn't crucial to the study of polynomials, but we'll get it down. You can have this out while you're doing your homework. It's not that big of a deal. So for the next one, what is its degree? What's the highest power I see? I see a 2. And we call those, this is the weirdest one, we call those quadratics, which just seems weird because quad means 4, but we call those quadratics. There's 1, 2, 3 terms, and just like bi for bicycle, tri for tricycle, or triangle, so we call those trinomials. All right, next one up. On this one, what is the highest degree I see? It's a 3. We call those cubic, and that's a pretty easy one to remember because you can kind of think of a cube and that you, like if you were doing volume of a cube, you'd say, well, it's, 8 cubic feet when you do something 3 times. So cubic is pretty easy to remember. This only has 1 term, so this would be called a cubic monomial. And this will take a while to get used to, just take some practice. And the last one, this is really a, oopsie, I'm sorry, scooted my viewing window over there a little bit. All right, so in the next one, what is its degree? It's 4, but shoot, I grabbed that again. Sorry about that. Anyway, right to here is really, if you can do 0, 1, 2, and 3, I'm good. The 4th one actually gets a name too. It's called quartic, and a fifth is called quintic, but it's really only, these are the biggies, and so make sure you know those. I won't test you and ask you about a quartic. Number of terms has 3, so we would call that a quartic trinomial. Now, anything beyond that, I would even say anything beyond 3, you can just go ahead and call it a polynomial, and I'm fine with it because, for example, let's put an example up there. Suppose I wrote this, 8x to the 7th, and I said to classify it by degree. You're just going to take this and say, you know what, that's a 7th degree. It doesn't really get any special name. This is 0 degree, 1st degree, 2nd degree, 3rd degree, 4th degree, but we give them special names at those levels. But once you generally get beyond 3, like even this one, a lot of people would just call it a 4th degree. And this would be 1 term. So we call it a 7th degree monomial. But again, it's up in here that it is the more common vocabulary. So let's move right along here. This is a good one, and see if you have all the vocabulary down. So I would suggest you pause the video and you go ahead and try to do this and see how you did. There's an infinite amount of right answers, so there's a lot of good stuff. But I'm going to go create one now, but you should pause it and give it a try. It says to create a polynomial, so I'm going to be linking some terms together, which meets all of these criteria. It has to be quadratic. What does that mean? It means the highest degree, if you want to go back and look at your chart, is going to be 2. So it's going to need an x to the 2nd as its highest. It has to have 3 terms. So it's going to have some sort of an x to the 2nd. It's going to have an x to the 1st, because it can't go higher. And then it's going to have to also have like a constant on it, like a 3 or a 4, because I need to have 3 terms in there. Now it says lead coefficient. Remember I told you those are those numbers out front. All right, let's start picking this apart. It needs to be quadratic. Its highest degree has to be a 2. Its lead coefficient has to be a 4. So everybody would have to have that locked in. Next, it says the constant term is 3. So somewhere in here I have a 3. It could be a plus, or actually it'd have to be a plus. And then it says the coefficient of x is 1. So you could have that. Actually, I said there's an infinite amount of right answers. Actually, for this one, I misspoke. This one only has this possible. Now, this is in standard form because I put my highest degree first, then my next one, then my constant at the end. If I were to say, hey, name this based on degree, you'd say 2nd degree, and you'd look at your chart, and for a while, you'd have to look, because it'll take a while to get those down. You'd say that's quadratic. Number of terms, 1, 2, 3. It's quadratic trinomial. So let's go and take a little practice here. It says, what is the degree of each one? Well, it's the highest power you see, and I see a 1. So this one is called a 1st degree. Next one, I told you that when you see, this is the least important, and we've actually decided not to test you on it. It's not huge, but when we have the 2 variables going like this, we add the exponents for the degree. Now this one, again, is kind of weird. You might be tempted to say it's 4th degree, but again, the power on the x is actually a 0. So it's a 0 degree. It's called a constant. So let's go down here and do a little practicing here. Write each in form. Now you forgot what that is, go back and look. And then we're going to give it a first name based on its degree. So if you were to have your notes and go back, we're going to give it a first name of one of these, and a last name of binomial, monomial, trinomial, etc. So let's go do a little practice on here. So first of all, standard form first. Highest degree is a 2, so that comes first. Then we have 3x to the 1st, and then our constant term on the end. So it actually goes 2, 1, and then this is x to the 0. It's in standard form. I'm going to give it a name based on its degree. Its 2nd degree, it gets a special name we call polynomials that are 2nd degree quadratics. And we're going to have a whole chapter 9 is just on those. A really, really important math concept is to be able to work with what we call quadratics. But for today, you did that. Now, it also says based on the number of terms, or how many monomials are linked together. 1, 2, 3. So we call it a quadratic trinomial. All right, next one up. What's my highest power? And that would be my c to the 7th, which has a negative 3 for a coefficient or number out front. Then I have my 8c to the 3rd, and then I have just my lone c. Next, I'm going to name it based on its degree. This is going way up there. We only need to know the 0, 1, 2, and 3 up to cubic, and then you can just say that this is a 7th degree. Those are actually the easiest because they don't have special names. So if that was an 11, I'd say it's 11th degree. If it's a 14, I'd say it's a 14th degree. So that's actually the easier when they go beyond 3. And it's 1, 2, 3 again. So I say that's a 7th degree. Trinomial. Isn't this exciting? Vocabulary is always just so exciting. I'm kidding. All right, so next one up. Putting this one in standard form is kind of interesting, but remember it's the highest degree on variable, so we've got to have that negative x first, and then minus 2. The constants, the ones without a variable attached, are always at the end. Now again, you might need to go look at that chart. That's going to be kind of your best friend for these. We've got first degree. If you look on your chart, let's go back a page here. If you look on your chart, when it's got first degree, we call it linear. Alright, so let's go back and get that one named here. So we have got what we'd call a linear, and it's got two monomials linked together, or two terms, so we call it a linear binomial. Again, that chart on the previous page, you can have that out for a while, and you'll get it. When we use that vocabulary more and more, you'll start not having to look. So the next thing up, we're going to discuss addition. In math, you can only add and subtract like terms. Again, another vocabulary word needed. Like terms have two properties. They have to have the same variables in them, but those variables also have to be to the same power. Some examples of like terms would be this: w to the 4th and 5w to the 4th. They have both have w's in them, and they are both to the 4th degree. How about this? 3x squared and 11x squared are considered like terms. Here's a pair that aren't like terms. 6 and 2x. Because this one doesn't have an x on it. So they have to have the same variables to the same powers. If they are, then we can just add them up. We would say this: I have 5p squareds plus 6p squareds. What does that give me? 11p squareds. Now, it's very tempting, I think, if I had you do this and put down what you think, I would have had a lot of people tell me it's 11p to the 4th. But let me just dispel that right now. It's kind of like this. If you have 5 dogs and add 6 more dogs, you have 11 dogs. They don't change when you add them up. You are accumulating like things. It's kind of, you know what I mean? Like 5 apples plus 6 apples is 11 apples. It doesn't change that base there. So let's take a look at this one. What do I have really? I have negative 1 out front of the x cubed, taking away 5 more x cubes. Again, treat this as kind of like a quantity. I'm 1 in the hole and I go 5 down. So I'm 6 in the hole of those. All right? This happens a lot at this level of math. Is that kids will get 10x plus 2 and they'll tell me that's 12x. No, it's not. It's 10 x's and 2 1s. It's not 12 x's. Watch me list it out. That'd be x, 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 x. There's my 10 x's, and then I have those. You notice you're not looking at 12 x's. So they have to have both the same variable to the same power. When they do, we can add them up. So let's put some examples on here of adding up some larger ones like this. So first of all, let's take 2x squared minus 4x plus 1, and I'm going to add to it x minus 5. So the first thing I would suggest you do for our notes is you need to do what we call combine like terms. I often will say, a lot of kids towards the end of the year, you'll know we start calling that CLT. We're going to combine our like terms, and we're just going to kind of, with the addition, you get to just remove the parentheses, because really, with addition, again, it doesn't matter what order. Let's go like that. Use stuff, and that's the same as 2 plus 3 plus 1 without even having the parentheses on it. So I'd suggest you might even want to consider this for a while. Just take those parentheses off for addition. And let's go add our like terms. Is there any like term that goes in with 2x squared? No. And the highest power. Then I've got minus 4x's, but I'm going up an x. That's really one of them. So a negative 4 up 1 would be minus 3x. Think of temperature. It's 4 degrees below, and it goes up 1 degree. And I'm at 1, and I'm dropping 5, so I'd have a minus 4. Now let's add a little bit. Let's add some vocabulary to this. I challenge you to, next to this, name it based on its degree and number of terms. And I pause this and write that down. What is it? Second degree would be called a quadratic. 1, 2, 3. Trinomial. And let's see how much I have on here. Okay, let's just go right to this page. And you go ahead and I would pause this and try, and then come back, turn it on, and check it. And then we are done with 8-1, day 1. So let's go take a look at what we've got here. First of all, I'm going to notice I'm doing addition. For addition, I get to just ignore the parentheses, and I don't even really need to rewrite it. I just did on that last one to show you. I'm going to my highest power, which is a 3. So this, is, again, we'd call that a cubic. And I'm adding another cubic, but that's my highest power. So I'm going to lead with those. I'm at negative 2 of those plus 4 of those gives me 2 of those. Notice I didn't change that to x to the 6th. I'm adding them, I'm combining things. When I put 4 people in a room with 10 people, I have 14 people. They don't morph into something else. Now, what I would do, so your answer is all in standard form, is go look for the next highest power. There it is. It has no friends or no like terms, so we're just going to write it down. Now with my x's, I'm at 1 in the whole. I put that in there. I'm at a negative 1x, and I'm adding to it another negative 1x. So I'm dropping negative 1. I'm dropping it 1 more. I'm going to be at 2 in the whole. And I'm at a positive 3, and then I'm going down 8. All right? And again, I challenge you to classify that. It's a little tricky because although it's cubic, because it's third degree, it has 4 terms. And that one didn't get a special name. Remember, it was 0 is 1 is a monomial, 2 terms is a binomial, 3 terms is a trinomial. But 4 terms, what do we call that? Anything beyond 3, we just call them polynomials. So we call that a cubic polynomial. And that's the end of 8.1, day 1.